Okay, so now we're going to do the equivalent resistance parallel lab. So we're going to be using the following resistors. Again, I don't know if you can see the color here, but it's brown, black, yellow, and then there's a gold. Okay. All right, so we're going to figure out what the resistance is for each of these individually. And then combine them together. Okay, so for resistor 1, let's see, it's off limits, 4K, off limits, 40K, off limits, 400K, it says 98.9. That's resistor 1. Resistor 2, I'm just going to put it right here and measure this. Resistor 2 says 98.2. Okay, and then I'm going to put two of them together. In parallel. And, oops, I don't think that one's done right. Okay, all right. And two of them in parallel reads 49.2 kilo ohms. 49.2 kilo ohms. All right, so resistor 3 now. Let's measure resistor 3. Resistor 3 measures 100 kilo ohms. And now let's put three of them in parallel. Kind of twisting the wires here together to make it easier to combine. Okay, so now let's try 3 in parallel. Looks like it's 32.9. Let me switch this down to a lower setting. .07 kilo ohms, 33.08 kilo ohms. Okay, and let's try another one here. So this is resistor 4. Resistor 4's actual resistance is 98.2 kilo ohms. So now we're going to put 4 of them in parallel. It gets tougher and tougher to put them together. Okay. And let's mark this down 1. All right, so 4 of them in parallel. And we get 24.74 kilo ohms. 24.74 kilo ohms. Okay. The fifth resistor has a resistance of 98.5. I'm going to put it in parallel. Attempt to anyway. Okay. And the resistance here is 19.77 kilo ohms, 19.78 kilo ohms. Okay. And finally, we're doing the sixth resistor, and its actual resistance is 98.2 kilo ohms. And the last one here in parallel. Like I said, it gets tougher and tougher to put them in parallel. All right, let's try that. All right. And this one is 16.46 kilo ohms, 16.46 kilo ohms. All right, so again, what I want you to graph is I want you to graph total resistance versus the number that was in parallel. This one is a little bit more challenging to try to figure out the relationship. You'll be able to graph it and linearize this one, no problem. But to figure out what the mathematical relationship is for any general situation, it's a little bit tougher. And so I think we need one more piece of data. So I'm going to keep, boy, can I get these apart? I'm going to keep one of these resistors. So again, the colors for this resistor was brown, black, yellow, gold. And again, the actual resistance, so you should be able to look that up on the color code chart. The actual resistance is for this one, oops, I'm off limits, is 98.2 kilo ohms. I have another resistor though that I want to look at, and let me look at this one closely here for a second. Let me get another one. Okay, so here's a different one. This one has colors of green, brown, red, and then there's a gold. So you can look it up in the color code chart. And let's find its actual resistance. Okay, so looks like I can go down one. Okay, whoops. Okay, this one looks like it's 5.07 kilo ohms. So that would be 5,070 ohms. Okay, I'm going to put these two resistors in parallel. you now have a mathematical model from your linearized one, but the problem is that that model is not very useful for figuring out any combination, kind of like what I have here. So let's look at what the resistance is for this situation. All right, so let's find out what the total resistance is. Okay, so it says that it's 4.82 kiloohms, 4.82 kiloohms. With that piece of information, we should be able to figure out a general model that would work for any situation.